All right, welcome to 12.1 on antiderivatives and indefinite integrals. So here we're going to be learning about antiderivatives, the indefinite integrals, formulas and properties, as well as applications. So what are antiderivatives? Well, a function f is an antiderivative of a function f if f prime is equal to big F prime is equal to f of x. Now, the function big F of x is equal to x cubed over 3 is the antiderivative of the function little f of x equals x squared because if we take the derivative of our x cubed over 3, remember we'd bring down the 3 and subtract 1, and then 3 divided by 3 is 1, and we have x squared. However, capital F of x is not the only antiderivative of x squared. So we could have, a 2, we could have pi, we could have the square root of 5. Any number is going to be the same thing because when you take the derivative of that, when it comes down to it, it all comes down to just x squared because this goes to 0, that goes to 0, that goes to 0. So all those pieces all go to 0. And so the only thing that really comes out is just this x squared. Okay. And so what we're going to do instead is we're going to call it have an x cubed over 3 plus some number c. So any real number c is going to work. Okay. So that's going to be our antiderivative of x squared. So if we took the derivative of this, we get x squared. So the antiderivative is going to be this. So we're kind of going backwards. We're going from there and we're getting this. So anti-differentiation of a given function doesn't have a unique function, but we get an entire family of functions. And that's because we could have any real number c here. So for our theorem one, we have antiderivatives. So if the derivatives of two functions are equal on an open interval a to b, then the functions differ by at most a constant. Symbolically, if f and g are differentiable functions on the interval a to b, and f prime of x and g prime of x are equal for all x in a comma b, then f of x equals g of x plus some k, some constant k. Okay, so that's going to be our kind of what we use for our c here. So what we're going to do here is we're going to kind of do some antiderivative. We're going to draw some graphs, and then we're going to figure out what does that mean. So first, we're going to find the antiderivative of f of x equals 3x squared. So what we're going to do is we're going to say, okay, well, for a, we're going to do it up here because we don't know how much room we're going to need. So that's going to be the antiderivative is 3x squared dx. And we want to take and find that. Well, we're going to find out that we can pull out that 3 out in front. And so that's 3. And then we have the antiderivative or the integral of x squared dx. Well, what happens is we're going to add 1 to this here. And so that becomes x cubed. Then we divide by that, whatever that value is, 3. We still have that 3 out in front. And then what we're going to do is we're going to just add on some c value. Now this 3 cancels this 3, and so this then gives us the function x cubed plus c. Okay, and so that's going to be our function of f of x. Okay, and so that's going to be the answer for A. Now B, what does this say? Well, it says graph the antiderivative of f of x equals 3x squared that passes through the point 0, 0, 0, 1, and 0, 2. All right, so with my drawing of functions here, this ought to be a good one. So we know we're going to go through 0, 0, 0, 1, and 0, 2. Now, what do we know about the function x cubed? Well, x cubed is going to look something like that. And so what's going to happen is we need to make this point here go through those points. So we're going to have 3 basically x cubed graphs that go basically through each of those points. And so it's going to be something like that. The next one's going to be something like that. And the next one's going to be something like that. And again, it's supposed to look all the same, but my graphing techniques aren't very good for drawings. So that's what it looks like in general as far as what they look like. So we are going through the point 0, 0, 0, 1, and 0, 2. Now, how are each of these 3 antiderivatives in part B related? Well, basically, we've just moved them up, up a piece, up a piece, and up a piece. And so what that means is they're vertical translations of basically of each other. And so basically, it's moving up by different values of C. So that's really the key piece. We're going different values of C we've added to that thing. And so that's going to be the key as far as what it's done. We moved it up or down. And it could have been maybe we started here and we moved it down. We could have started here, we moved it up one and we moved it down one. Or it could be this is the original and we've only moved it up. So that's how that works. So let's stop there and we'll come back for some more.